I think you guys are ready. It's time. Let's do it. Vanilla JavaScript and HTML canvas are powerful tools, and today we will add many useful tricks and techniques to our front-end web developer coding toolkit. I will explain how to build this effect completely from scratch with no frameworks and no libraries, and in the process I will show you, for example, how to turn your drawings and animations into watercolor effects, shaded paintbrushes, and much more. Today I want to share some of my secret animation techniques with you, and the biggest secret is, it's actually much easier than you think to make effects like this. You just need to understand a couple of basic principles. I will cover all of them with you step by step right now, and I can't wait to see what you guys do with it. Click the like, please. There are so many videos on the internet and you are watching educational content right now in your free time. That's really amazing. I wish you a lot of success in your future coding career. I'm here to help. I'm trying really hard to keep you interested in JavaScript by showing you all different kinds of cool things you can do with it. For me, building visually memorable projects is a good way to practice front-end web development, and I hope it motivates you to keep going until you reach your goals. I will go a little bit faster than usual. If this is your first HTML canvas or JavaScript project, maybe you should check my beginner playlist first. Over there we also create many cool things, but I take time to explain everything slower for beginners. I will link it in the video description. Let's set up our canvas. Constant variable called canvas will point to the actual HTML canvas element using getElementById. CTX context is canvas.getContextToD. We are using a set of 2D drawing methods today. Now we can call all of them from this custom CTX variable, but if I go ctx in VS Code editor, I don't get any suggestions for built-in canvas methods. If I want them to show here, I can just tell my editor that this is HTML canvas project. I do it by typing a comment up here like this. Now I get IntelliSense for my CTX variable with all canvas 2D properties and methods. I set canvas width and height to cover the browser window, same as I did in CSS to make sure we get the correct scaling. I want to create animated root or flower stalk that grows at random speed and moves in random directions. I create a custom class I call, for example, root. Constructor will expect x and y properties as arguments. This will allow me to attach the initial growth points to the current mouse x and y coordinates. I want the root to grow in all possible directions, so each root will have horizontal speed variable I call, for example, speed x. It will be a random number between -2 and +2, like this. I do the same for vertical speed y variable. It needs to be a number between equal positive and negative values, because in my final effect I want to have my roots come in a circle from the current mouse coordinates in all possible directions. The roots will grow until they reach a certain point. I will define it as this.max size, and it will be a random number between 5 and 12 pixels, for example. This.size will be the initial size before they start growing, and it will be a random number between 2 and 3 pixels. We will use a trick with requestAnimationFrame method where we draw many roots, but each one will have its own separate animation loop. I don't know if this is more or less performant, I need to test it. All I know is that it works really well and creates nice organic growing effect. Let me show you. Each animation frame will update this.x from line 9 by this.speedx from line 11. Particles that have positive speed x value will move to the right, negative will move to the left. At the same time, we will add speed y to particles this.y position, so negative values will move upwards and positive values will move down. Speed x and speed y combined will create a random vector, which is direction and speed of movement for each individual root particle. I want the roots to grow. I will increase their size by 0.1 pixels for each animation frame. As long as this.size from line 14 is less than this.max size from line 13, we will draw a new segment of the root to make it grow. Each segment will be a simple green circle. CTX begin path to start the drawing, CTX arc method to draw a circle. I pass it x, y, size, start angle and end angle like this. I want to create dynamically calculated fill color. For now, let's just hardcode green. With HSL color declaration, green is around a value of 120 degrees on HSL color wheel. Saturation 100% and lightness 50%. I will get back to this in a minute. Now I fill the circular path with green color and I also stroke it. This will give it border. If I don't declare stroke style, it will default to black color. So for each frame, we move the root along horizontal and vertical axis. We increase its size, and as long as its current size is less than max size, we draw another circular segment. I will make this into an animated paintbrush, so let's attach our drawing code to mouse position. Window at event listener, and whenever Mousemove event occurs, I will run this callback function. Callback function on event listener has access to built-in event object that stores x and y coordinates of that mouse event. I need to assign it a variable name like this. I will call my event object e, for example. Every time a Mousemove event ticks, I create a new constant variable called root, and I set it equal to new root like this. On line 8, I can see that my root class constructor expects x and y coordinates. It needs them to know where on canvas it should start growing from. So as x coordinate, I pass it x coordinate of this Mousemove event, e.x, and as y, I pass it y coordinate of where this tick of Mousemove event occurred, e.y. Since this root variable now holds a single instance of my root class, this root object has access to update method I created on line 16, so I can call it like this, root.update. Let's see what happens when I move mouse over canvas. We are drawing something, but what exactly is going on? Well, we are creating new root object and each one runs its update method only once. I'm not clearing old paint from canvas, so we see old frames as well. Everything is working well, but I have some code here where I gave my root behavior. For this behavior to have any effect on canvas, I need to call update method over and over again as long as size is less than max size, as long as this condition is true. To make update method run over and over for each of these individual root objects until this condition is met, I can just put a requestAnimationFrame inside this if statement like this. That way, we update position and size, and if size is less than max size, we draw another segment, and requestAnimationFrame will call update again to create another segment. I can't just pass it update like this, because update is a method on a class. I need to call it using this keyword, because I instantiated my class here, and I'm calling it from this variable. It will still not work. I can see that update still runs only once for each object. Let's inspect browser console to help us understand why. It says cannot read property x of undefined on line 17. JavaScript is trying to run this.update again, but it gets stopped at this point. Apparently, this dot is undefined. JavaScript forgot what this keyword refers to. To help JavaScript remember which object this keyword is pointing towards, we will use built-in bind method. Its simplest use case is to make function such as our update method here, no matter how or from where in our code it's called, it will make sure it is called with particular this value. It will bind this keyword to a particular object. Here on line 26 I'm saying serve another animation frame by running this function called update, and make sure it remembers that this keyword used in that function refers to this particular root object. This is a bit advanced if you are a complete JavaScript beginner, but I won't go into more details. It has to do with scopes and closures, which are important programming concepts you will eventually have to understand. Especially closures are one of the most challenging topics for beginners, so don't worry about it right now. Take your learning step by step. All that we need to know right now is that calling requestAnimationFrame like this makes JavaScript forget what this keyword refers to, and to make sure it remembers, we bind this keyword to subsequent calls of update method using built-in bind method. Now it works. We are dropping new roots on canvas and they grow as long as this if statement is true. As long as the current size of this green circle is less than max size, update method will keep calling itself again and again. Now we know the main mechanic. Let's play with it a bit to make it look nicer, and then we will use the same technique to make flowers grow from the tips. I don't like how my roots are growing in straight lines. I want them to curve and look more like an organic structure. There are multiple ways to do that. Today we will use trigonometry. I create this .angle property on my root class. I can initially set it to 0, or I can also set it to a random number between 0 and 6.2. I did 6.2 because that's roughly a circle in radians. 360 degrees is 6.2 radians. The initial value doesn't really matter much at this point actually, now that I think about it. You can leave this dot angle at 0 at first. On line 18 we are increasing horizontal x coordinate by the amount of speed x from line 11. Let's do plus Math.sin and I pass it this dot angle from line 15. Nothing is happening yet because this dot angle is a static value. It needs to be changing so that Math.sin can use it as an angle value argument and map it along a sine wave. Let's do it first and then talk about what's happening. I need to make sure angle is an ever increasing number. Let's try this dot angle plus equals 0.1. Nice, now we have some curves on our roots. Math.sin takes ever-increasing angle as an argument and it uses that to map coordinates along a sine wave curve. It will basically oscillate back and forth between +1 and -1 endlessly, making this .x property go left and right in regular curvy movement. Let's do the same thing for this .y to add a bit more randomness. Now this is starting to look pretty organic. Look at all that randomness. We can make it a bit more irregular. I don't want symmetry in this case. Plants don't grow in symmetrical curves. First, let's randomize growth speed. On line 21, each root is increasing its size by 0.1 per frame. They all grow at the same speed until they reach max size, which is randomized for each root here on line 13. Let's create a property called VS, velocity of size. It will give each root a different growth speed. And when I say growth speed, it doesn't affect which direction it moves. That is determined by speed.x and speed.y variables. Growth speed in this case means just the size of the circular particle that draws our roots. Because we are using this .size here on line 25 as a radius to draw these circles. So VS, velocity of size, will be a random number between 0.05 and 2.05. I need to give it some small minimal value at least. So this .size plus equals this .vs. Now my roots are short. This .size reaches max size very fast and they stop animating because of this if statement on line 23. Let's make this .vs a smaller number so they grow slower. Nice, we have more randomness. How about we also randomize the speed at which angle changes value on line 23? I do that by creating this .va variable, velocity of angle, and it will be a random number between 0.3 and 0.9. I increase angle by this .va on line 23, and now some of them grow straight and some of them at randomized curved shapes. It's still symmetrical. What if I create angle x and angle y, and velocity of angle x and velocity of angle y properties? As we pass these even more randomized values to Math.sin on lines 22 and 23, we are finally starting to get irregular asymmetrical trails. Nice! I can play with movement longer, but I think you get the idea. Feel free to run your own experiments here. Let's try to give it a little bit of 3D effect, for example. I will make the roots start from dark shade of green and go lighter as they grow. It might create an illusion that they are growing upwards from darkness towards the light. Let's see. On line 30 we have HSL color declaration. Hue, saturation and lightness. Lightness defines how much is the color affected by light or dark. 0 is black, 100% is white, 50% is full color, not affected by light at all. I will replace it with a variable like this. I will call this new value this.lightness. It will be a property on my class and it will start at, for example, 10. In update method, I say as long as this.lightness is less than 70, increase it by a small value every time we draw a new root segment. Now they start at lightness 10 and as long as they grow for long enough, they can get all the way to lightness 70. I want more roots, thicker growth. Inside Mousemove event listener on line 39, instead of drawing just one root every time a Mousemove event ticks, I will create multiple ones coming from the same point. I do it by wrapping all of this inside a for loop. Let's try 3 roots each time, for example. This looks much better, don't you think? I said we would make this into a paintbrush. Right now, it just draws all the time when mouse moves over canvas. What if I want to draw only when mouse is pressed down? On line 7, I create a global variable called drawing, and initially I set it to false. I will only add new roots if drawing is true. I create an event listener for mouse down event. When mouse button is pressed down, drawing is true. Another event listener for mouse up event. When mouse button is released, drawing is set to false. Now we only draw new roots when mouse is pressed. I want flowers to grow from my roots when the root itself reaches maximum size and stops growing. I want these flowers to also be animated, so now I have to structure my code somehow in a way that waits for the root to reach maximum size, and then new animation loop kicks off at the location where the root stopped, and it will animate growing flower from there. Does it sound like a challenge? It's actually easy. We already did it earlier in this video. Let me show you. I create a custom JavaScript class I call, for example, flower. Constructor will expect x, y, and size to be passed as arguments. We need to do this because we want the flower to start growing from the last coordinates of the root, and we also want the size to be affected by the final size of the root. I could draw the flowers entirely with code, but today we will use a sprite sheet. I will leave a link to example sprite sheet you can use in the video description, but you can also use your own. I bring it into the project like this. This.image is equal to new image, and this.image src source is flowers png. Your source path might be different. I want flowers to grow from their initial size, which will be passed from the outside, until they reach certain maximum value. I will call it this.maxFlowerSize. It will be their initial size plus random number between 0 and 50 pixels. I will give my flowers behavior by creating a custom method on my flower class. I will call it, for example, grow. As long as size is less than max flower size, I want size to increase by a small value for each animation frame. Now I will call built-in drawImage method. It requires at least 3 arguments: image we want to draw, and x and y coordinates where on canvas we want to draw it. Now, how do we trigger this grow method? On my root class, this custom update method is drawing new segments of each root as long as the size of the root is less than its max size. I will add else statement, so when the root reaches maximum size, I create a constant variable called, for example, flower, and I set it equal to new flower. On line 45, I see my flower class constructor expects x, y, and size, so I pass my new flower this.x, this.y, and this.size of the last segment of the root, like this. Here, this.x refers to the root because we are inside update method on the root class. I can call grow method on my flower variable like this. It works, it's drawing the entire sprite sheet with all 9 frames. I will pass my draw method optional 4th and 5th argument. These are used to set width and height of the image, and they can scale the image up or down. This is too small. Size times 5, just so we can see it's still drawing the images. I will use the longest version of drawImage method that will give us the most control over the image. I give it additional 4 arguments called source x, source y, source width, and source height. Now we have 9 arguments in total. Image we want to draw, x, y, width and height of rectangle we want to crop out from the source image, and x, y, width and height for where on canvas we want to place that cropped image onto. I will need frame size property. My sprite sheet is 300 times 300 pixels and we have 3 images per row. Each flower on this particular sprite sheet is 100 times 100 pixels. First, let's just crop out the first frame. I crop from coordinates 0, 0 to frame size as width and frame size as height. The flower is there, but it's very small. That is because grow method doesn't loop yet. It just runs once, draws a small flower, and that's it. First of all, I need to put a draw image inside this if statement. Now again I call requestAnimationFrame, and as long as size is less than max flower size, I want this grow method to call itself over and over, animating my growing flowers. I need to use bind keyword again to make sure JavaScript remembers what object this keyword refers to on its subsequent calls. Awesome, we have flower growing from the tip of each root. We are only drawing this flower at coordinates 0, 0 because we have hard-coded these coordinates here on line 59. Let's randomize that. Frame y will be vertical coordinate, so a random number between 0 and 3. This will give us values with the decimal points, but there is no coordinate 1.5, for example, so I need only integers, so I wrap it in math.floor. Now, frame y can be vertical coordinate 0 or 1 or 2. Frame x will also be 0 or 1 or 2. These coordinates combined will assign random x and y coordinate to each flower object, so each time it will grow a different randomized flower. For example, x1, y2 will be this one. Now, on line 60, I replace hard-coded 0, 0 with this.framesize times this.framex for horizontal, and this.framesize times this.framey for vertical crop. Awesome, we are using all 9 flowers now. drawImage draws a rectangle, so by default my flowers grow from top left corner. I want to center it, so I need to offset current destination coordinates by half of the current size to make sure flowers grow from the center, like this. Yes, what else? Maybe I don't want there to be so many flowers. Let's just draw flowers on the largest roots, not on all of them. I will use ES6 ternary operator, which is basically a one-line if-else statement. I will say if initial this.size is more than 11.5 pixels, give it property called this.willFlower and set it to true, else set it to false. Ternary operator is just a simple if statement. If this condition is true, question mark, do this, else, colon, do this. I kinda like this syntax actually, it's simple and clean. Inside grow method, I only want to draw the flowers if this.willFlower is true. Also, let's try to increase max flower size on line 50. Now, only the biggest roots that had final size more than 11.5 pixels will sprout flowers. And they are too big. I want each flower to grow at a different size, so this.velocity of size vs is a random number between 0.2 and 0.5. And here, this.size plus equals this.vs. Now, some grow slower and some grow faster. Maybe I want flowers to spin when they grow, and I want them to randomly spin at different speeds, some to the left and some to the right. Canvas rotation is a bit more complex topic for beginners, and I have a special episode on that. Today, just quickly, this.angle is 0. We will use that as the initial rotation angle. When you want to rotate individual elements on canvas, you need to wrap that drawing call in between built-in save and restore methods like this. Let's just do it and then I will recap what's happening. Canvas translate method needs to be used to set rotation center point. Otherwise it will rotate around coordinates 0, 0 on canvas, and that will just look like a big mess. This used to confuse me so much when I was a beginner. So I call translate and I pass it this.x and this.y of this particular flower. That will bring rotation center point over that flower we want to rotate. Then I call built-in rotate method and I pass it this.angle from line 58. Translate method basically moves what would be coordinates 0, 0 on canvas to the coordinates we passed to it. So now this.x and this.y is treated as if it was coordinates 0, 0. That's why I need to replace this.x and this.y inside the draw method with 0, 0 to make sure flowers are drawn where they are supposed to be. Yes, this works. I want each angle value to increase at different speed. I also want some to be negative and some positive values so that some flowers spin to the left and some spin to the right. This.va, velocity of angle, will be a random number between minus 0.5 and plus 0.5. Now I increase this.angle by this.va, and since we are passing it to rotate method here, the flowers are spinning now. Wow, they are spinning way too fast. I will make this.va a much smaller value range. Perfect. So, rotation on canvas works in a very specific way. First, we wrap the thing we want to draw between save and restore methods. We save current canvas settings. We translate rotation center points, what is usually coordinates 0, 0, over the flower we want to rotate. We also need to replace this.x and this.y with a 0, 0 inside the draw method because of that. Then we rotate the entire canvas context by passing it this.angle value that is slowly increasing on line 64. Then we draw that rotated image and we call restore, which will jump back to save and restores canvas settings to what they were initially, removing translates and rotates that happened in between. We need to do it because each translate and rotate calls normally add up, and it would just displace our canvas completely off screen if we didn't restore. Canvas rotation can be a complex topic. If you are a beginner, don't worry about it too much yet. Time for experiments. What could we do with this? How about we change line width to 0.5? This affects the black stroked border on the root circles. 0.2. Now we see a lot of green. 0.4. globalCompositeOperation could also be interesting. I call this particular one watercolors effect. For some reason I really like this. It kind of looks hand-drawn to me. You can see there is a lot of randomness going on with these roots. We did a really good job making these strokes look chaotic, like a natural growth or like handmade strokes almost. Difference operation doesn't look very nice here. Destination over will make our effect grow backwards. For some reason I also really like this. It looks really weird in a good way. It only draws roots when I press and drag mouse on canvas. I also want to create explosion of roots whenever I click on canvas. I can copy this for loop inside my mousedown event. It won't work unless we pass it event object here, because we are using E in our root class for coordinates. Now, when I click, I get 3 roots. I wouldn't call that an explosion. I want to create 30 roots when I click. Much better. Now we can draw roots on Mousemove and on click. At this point, I have explained all the techniques we need for this effect. Now we can just experiment and combine different HTML canvas animation techniques to create many different variations. We can make a lot of beautiful things with this. Let me show you. First of all, I will delete the entire flower class. If you want to have a backup, you can copy the code files to a different folder, so you have a reference how we did this. We can use images in this effect, not only for flowers, but also for the roots. It could look something like this. But what I want to do right now is to use only canvas shapes. I also delete this else statement between lines 40 and 43, and I delete all drawing code that draws our green circles. Now we have a blank canvas and a nice boilerplate code base. We can take this in so many different directions. Let me show you something cool. On line 34, I set fill style to FFF5DE. I call fill rectangle built-in canvas method and I pass it X, Y, width and height. It's very light, so in style CSS I give my canvas a background. I will do linear gradient between these two colors. Back in script.js, I go up to line 17 and I make max size larger. This will make the trails very long, so I will also make sure the shapes grow faster here on line 19. This is better. On line 36, I declare stroke style. Let's do something darker. 3C5186 for example. And I will draw stroked rectangle. I also pass it X, Y, width and height. I'm going for a 3D effect. I want it to look like this brush has a depth, like it's 3-dimensional. Wish me luck. We already learned how to rotate something on canvas, so let's repeat the steps here. First I wrap whatever I want to draw between save and restore. To make sure, rotates and translates only affect this particular shape, and other shapes can rotate at their own speeds and directions. Then I translate what would be coordinates 0, 0 over the shape we want to rotate. I will translate rotation center point over my rectangle. Since my rectangle's coordinates are now considered point 0, 0 on canvas, that's where I want that rectangle to be drawn, so I replace this.x and this.y with 0, 0. Now I can call rotate and pass it this.angle. I create this.angle property inside my constructor and I set it initially to 0. VA, velocity of angle, will be a random number between two very small values. And inside update method, this.angle plus equals this.va. And we are rotating. We are getting better at this. Practice makes perfect. I actually don't need to redeclare fill style and stroke style every time update method runs, since I'm not swapping between colors or anything. Let's just declare them globally up here, which will save us a little bit of performance. Still works great. Let's try line width 0.5, or make it thicker with 2 pixels maybe. We can add more global canvas properties here to improve and transform our effect. Let's try shadows, for example. ctx.shadowOffsetX will be 10, shadow offset y will be 10, shadow blur may be 10 as well, and shadow color red. Okay, it works, but it doesn't look great, does it? Let's change shadow offset X to 0, shadow color black, or maybe some opacity, RGBA 000, which is black, and 0.5 for opacity. Line width 0.2 pixels. Down on line 48, I make stroked rectangle bigger. Line width 1 pixel. 0.5 pixels. Rectangles are drawn from top left corner, so I need to center them. I offset them by half of their size, same as I did with flower images before. I also need to offset the stroked rectangle, but first let's put size times 2 operation into a variable to make the code cleaner. I will call that variable double, for example. I replace double as width and height, and I offset x and y by half of double. Now, filled rectangle is exactly in the middle of stroked rectangle. Nice. Let's add another stroked rectangle, and I call the variable triple. It will be this.size times 3. It needs to be a different color, I think. I bring stroke style back inside my animation loop, and I set the second one to white. I also take line width and bring it here. The first stroke will be 0.5 pixels, and the second one will be 0.2. Up on line 16, let's set globalCompositeOperation to lighter. XOR. Destination over will make us draw backwards. This looks interesting. I make the second stroke thinner on line 54. You can change shadow color to stylize your effect. I can play with this for hours. On line 55, I set the initial size to 0 to make the inner seam thinner. I comment out stroked rectangle between lines 51 and 56 so that we just see the original filled rectangle. Let me know what you've built if you really like your version of this effect. You can post it on Twitter and tag me in it. I want to see who followed this tutorial and coded with me. Check out my playlist if you are still feeling creative. I'll see you there.